as a continuation of our work with complex numbers, we're going to look at dividing complex numbers. Now, there's some extra steps to this, so we're going to do a few examples, but I need to give you a little background. I want you to, first of all, before you take a look at this lesson, make sure you try these three problems, 2 factoring and 1 solved by factoring. It does not have to do with these complex numbers problems, but it gives you a little bit of time to review and go over your factoring as part of the process of reviewing for this chapter. So when you're ready, let's take a look at the notes for dividing complex numbers. So when dividing complex numbers, we need to focus on simplifying by eliminating the I in the denominator. Now what we're going to do for this one, I'm going to give you a little background here because we're going to use this kind of fact in what we do. Just a reminder that whenever you have a number over itself, that's equal to 1. 3 over 3, it's equal to 1. -5 over -5 is equal to 1. Even when we deal with an imaginary number, the imaginary unit over itself, that's equal to 1. If you have even a binomial complex number, this is a complex number, but when it's over itself, it's equal to 1. So any number over itself, it becomes just equal to 1. Now we're going to use that in working with these problems. First of all, we want to talk about what's called the complex conjugate. That's some background here. Complex conjugate is if I've got a plus bi, that complex number, its conjugate is a minus bi. Now a conjugate, all it means is if you've got a binomial, you just have if it's plus in the middle, its conjugate is a minus. If you start with a minus in the middle, its conjugate is a plus. The reason why that's helpful is it draws upon the difference of two squares pattern, and that difference of two squares pattern is going to help us in simplifying some of our division problems with complex numbers. All right, so let's look at then, so just as an example, just a quick example, if I have 5 plus 3i, then 5 minus 3i is the conjugate. We call them complex conjugates, but we'll also later on talk about radical conjugates. All right, so let's talk about the two different types of problems we'll have. When you have a single term within your denominator, okay, then here's an example. If you've got, for instance, 3 over 5i, so a single term with an I in the denominator. This is the simplest form of being able to simplify. We're going to draw upon this I over I equal to 1 fact. If I multiply this by I over I, this is equal to 1, which if you multiply by 1, that doesn't change the value of this at all. Multiplying by 1 doesn't change the value, it just changes the form. So when I get this and multiply 3i over 5i squared, this has the same value as our original 3 over 5i, because all I've done is introduce a factor of 1. But here now, that I squared, that's something that we can simplify. That becomes a -1. And now, because of that -1, I can make this -3/5 I as my final answer, where the I is no longer in the denominator. This 3 over 5i and -3/5 I, exactly the same number, just in a different form. Let's do one more. Let's try, let's do 4 plus 2i over, and let's have in the bottom, let's say 6i. So if there's a single term in the denominator, you multiply by I over I, which is equal to 1. Distribute through the I, so you can get 4I plus 2I squared. And on the bottom we'll have 6I squared. And how we rewrite this is we're going to have 4I plus, what is I squared equal to? It's equal to -1. -1 times 2 gives me -2. So you can make that a -2. This I squared is equal to -1. So -1 times 6 is -6. And now I'm just going to rearrange it so that the real part is first, imaginary part is second, and I'm going to separate it. So I'm going to make it -2 over -6, and then plus 4 over -6i, which will simplify to -2 over -6 reduces down to 1/3. This is a minus because there's a negative there, and this will be a 2/3 I. So that's in the form we want it, with the real part and then the imaginary part of the problem. So it's okay to have i's outside or i's in the numerator. What we don't want to have when we simplify is to have an I remain in the denominator. You've got to multiply by this I to get it out of the denominator. Now what happens instead if we've got two terms on this? We've got two terms. For instance, as an example, if we had 5 over 2 minus 3i. All right, now that's two terms in the denominator. What we're going to do is we're going to use this conjugate idea. The complex conjugate, that if I've got a 2 minus 3i, if I multiply it by 2 plus 3i, it's going to draw upon the difference of squares pattern and get rid of the I in the denominator. So I'm going to multiply by it in both the top and the bottom. So 2 plus 3i over 2 plus 3i. So now when I multiply this through, that's the conjugate of the denominator. You don't worry about conjugates of the numerator, just always look at the denominator, multiply by its conjugate. Now I'm going to distribute through the 5. 5 times 2 is a 10. 5 times 3i is a 15i. In the bottom, I'm going to go ahead and do my double distributive. 2 times 2 is 4. 2 times 3i is 6i. Negative 3i times 2 is negative 6i. You see how that's going to get rid of those I terms. And then negative 3i times positive 3i is negative 9i squared. Now we'll have 10 plus 15i in the top. In the bottom, notice what we have here. These two get rid of each other, so we no longer have those. And this I squared is a -1. So I'm going to have instead down here 4 plus 9, because -1 times -9 is going to equal a positive 9. And so I end up with 10 plus 15i over 13 when I add those two together. Now we're going to talk about this in a moment, what the format of the answer is. You don't want to leave it in that form. We want to separate the real and the imaginary part. This is really the answer, and if you get that far, you're in good shape. But we do want to separate it into 10 over 13 plus 15 over 13i. Okay, let's do one more example. So let's say we have, as this problem, we're going to do 2 plus 5i in the top, and in the bottom we're going to have 6 minus, let's do just 1i. So 6 minus 1i. Now, you don't worry about a conjugate in the top, you worry about the bottom. So the conjugate of 6, let's make this a 6 when we do the conjugate, it's going to be 6 plus I. You do it in the bottom, but you're also going to do it in the top. When I multiply this out, now I've got to double distribute in the numerator as well. So 2 times 6 is 12. 2 times I is plus 2I. 5I times 6 is 30I. And then 5I times I is just plus 5I squared. All over, and in the bottom, 6 times 6 is 36, plus 6I, minus 6I, and then minus I squared. Now let's combine like terms. I'm going to, on this one, remember the I squareds are going to be equal to -1. So what you get here is 12. 2I plus 30I is 32I. 5I squared is equal to -5, because the I squared becomes a 1. Down here is 36. No more I's in the middle. The 6I and the -6I get rid of each other. Minus a -1 is going to be a plus 1, because I squared is equal to -1. Just going to write that over here again. We keep using this fact, and it's something we can't overemphasize, that I squared is equal to -1, because we keep using it. So this is equal to 12 minus 5 is 7, plus 32I, all over 37, and then we separate it. 7 over 37 plus 32 over 37I. Real part and imaginary part. So remember, you want to separate real part from the imaginary part when you do your final answer. Real from imaginary. Okay, so what we've done is we've done the 2 different types of division problems we're going to do with fractions. We're looking primarily at fractions here. And when we have the single term, you just take advantage of the fact that I over I is equal to 1. Multiply that through, simplify. When we have a binomial or 2 terms in the denominator, multiply by the conjugate. If this is a minus, make it a plus. If it were a plus, you'd make it into a minus. Top and bottom, because you got to multiply by a factor of 1 to not change the value, just change the form. And then we multiply, simplify, and then separate, and the final answer, separate your real from your imaginary part.